Alright, so continuing on with streams. Now, we wouldn't be able to use a map method with a method that expects two arguments here. I'm talking about the code on line 30, because that method can't be mapped to a function. Now, the map method wants a function, not a by function. And of course, we don't want to have to pass a method reference. Now, we can also pass a lambda that matches the function pattern, accepts one argument, returns one value. In this case, there just happens to be a method in the string class that does what we want to do. Now, obviously, the method that we use has to work with the item types in the stream. Now, we couldn't use a string method if the items in the stream weren't strings, for example. So the map method ultimately returns a stream. The stream will contain all the uppercased bingo numbers. In other words, it will contain all the results of calling the toUpperCase method on the input stream. Now, it's called map, by the way, because it's essentially mapping each item in the input stream to the result returned by the function argument. Now, the resulting stream will have the same number of items as the source stream. In this case, the source stream is the result of the sum bingo number.stream call. Now, remember when we chain together functions and a function in the chain would operate on the result from the last function in the chain? Well, essentially, this is what's happening here. Each stream operation operates on the stream result from the last step. Now, so far we've created a stream from our collection and passed it to the next operation in the chain, the map in this case, and now we have a stream containing uppercased bingo numbers. Next though, we want to filter the stream so that we end up with a stream that contains only those numbers that start with G. So we're going to use the filter method, that's the code on line 31, to accomplish this. Now, the filter method wants a predicate, not a function, so in this case we're passing a lambda expression that takes one parameter and returns a true-false value. The resulting stream will then contain only those items for which the predicate returned true. So at the end of this operation, we'll have a stream that contains ultimately the 5 G numbers. Alright, so moving on, in the next step, we sort the items by calling the sorted method. So this method sorts based on the natural ordering of the items in the stream. Now, there is also a version of the sorted method that accepts a comparator parameter, but we don't need to provide one in this case. The natural ordering will suffice, but again, the option's there if you chose to do that. Then finally, on line 33, we're printing out the results using the for-each method. But, important note here, this for-each method isn't the same one that we've previously used with the iterable interface. In this case, we're using the for-each method from the stream class. And in fact, all the steps have used methods from the stream class, which if you think about it, should make sense. And that's because the object type returned from the stream method is a stream. And therefore, from that point forward, every method we call operates on a stream, namely the stream returned from the previous step. So the stream for-each method does what the iterator one does. Essentially, it accepts a consumer as a parameter and evaluates the consumer for each item in the stream. Now, since the system.out.println method accepts an argument and doesn't return a value, we can map that to a consumer. And that's what we're doing on line 33. We can then pass it to the for-each method, and we've done so using a method reference, as you can see. So in previous videos in this section, we saw that the iterator.forEach method takes a consumer argument. So you might be wondering, could we have passed it a method reference, something like this, a code like this that we've worked on previously, so list.forEach. So my question is, could we have done this? System.out, a method reference, println. Could we have done something like that? Absolutely, we could have. But we needed to learn how Lambda expressions map to the interfaces in the java.util.function package before we started to use shortcuts, which is why we did sort of something along these lines. Which was sort of the longer version of what we've got on the previous line, rather than doing what we can essentially do now that we've learned how to do it, which is class : method and using a method reference. Alright, so I'll just delete those. Now, since the forEach method doesn't return a value, the chain has to end here because we're on the last line effectively. So there's nothing to pass on to another step at this point, again, because the forEach method doesn't return a value. So basically there's nothing to pass on to another step. Now, because of that, the for each method is called a terminal operation. So a terminal operation returns either void or a non-stream result. Now, since every operation in a chain requires a source stream, ultimately the chain has to end when we use a terminal operation. Now, operations that return a stream are called intermediate operations because they don't force the end of the chain. Alright, so let's have a recap on what our stream chain does and look at the results of each step. So firstly, when a chain is evaluated, a stream pipeline is created. Now, the stream pipeline consists of a source, 0 or more intermediate operations, and then a terminal operation. Now, in our example, we used a collection as the source, but we could also have been, or it could have been, an array or an input-output channel, and we can build streams from scratch. The items in the source enter the pipeline, and the chain result emerges as the other end or at the other end of the pipe. Now, as we've seen, elements may be removed from the stream as a result of an operation, so the set of elements that comes out at the other end of the pipe doesn't have to match the number that entered the pipe. Also notice that when we weren't using streams, our G64 number was printed with a lowercase g. But when we use streams, it was printed with an uppercase G. In the non-stream case, we didn't use the result of the two uppercase call, and that was the reason for that. And when an item passed the test, we assigned the original string with the lowercase g to the new list. But in the stream case, the map method maps each source string to the function result. So therefore, the uppercase string is added to the resulting stream and ultimately passed to the next step in the chain. So that's why the non-stream case prints a lowercase g and the stream case prints an uppercase G. Alright, so let's have a look at what else we can actually do with streams. So rather than creating a stream based on a collection, we can create one from scratch. So let's actually look at doing that. Now we're going to be using the stream.of method to create a stream comprised of some numbers from our bingo numbers list. Now we could do it by changing the stream chain we've just discussed, but I want to show you how to use the of method instead. So let's look at doing that. So I'm going to type stream string IO number stream equals, and we'll do stream.of. I'm going to put I26, I17, I29, the last one O71. So that now gives us a stream of string objects. Now we can create streams composed of any type of object, but we can't create a stream of mixed types. So for example, we couldn't have a stream of string and employee objects. Alright, so let's create another stream that contains the I and N bingo numbers. Stream string int number stream, so I and N. That's going to be stream.of again. And N40, N36, I26, I17, I29, and O71. Alright, so let's now concatenate these streams together. And we can use the concat method to actually achieve that. So we can type stream string, and we'll call it concat stream is equal to stream dot concat, then IO number stream, then IN number stream. Now note that the concat method is static, so we can't use it in a chain, but we can use the result as the source for a chain. So let's actually print out the number of items in the concatenated stream. And we can do that with a printout, system.out.println. Then we can do concat stream.count. Now since count returns a long value, it's a terminal operation. So when we run, we should see number 10 printed on the console, which is the total count of both streams. We can see 10 showing there. Alright, so right now our stream contains duplicate numbers, but we can remove them using the distinct method, which uses the equals method to determine which objects are duplicates. So in this case, the stream contains string objects, so the method's going to use the string.equals method for comparison purposes. And we're going to chain the distinct and the count operations together so that we're printing out the number of items that remain after the duplicates are removed. So I'm just going to go back in here to this concat stream.count. I'm going to put dot distinct, then follow that up with a dot count, like so. So now if we run that, we should get the number of unique elements. You can see we've got the result there of 6 because it's removed the duplicates. Essentially the 4 items have been removed in this case. So a question here, can we print out the items in a stream but without ending the chain? So let's just say that we're trying to debug a long chain and we wanted to print the results of each operation in the chain. Now we know that we can use the for each method, but that's actually a terminal operation. So instead, we could use the peek method, which accepts a consumer argument. Now it evaluates the consumer for each item in the source stream and then adds the item to a new stream, which it then returns. Now since it returns a stream value, it's an intermediate operation. In other words, the chain doesn't have to end. So let's try it. So right now we're printing out the number of distinct items. So let's actually print the items out before we call count so that we can verify that the items in the stream are actually distinct. We can also print out a dividing line so that we can separate what's being printed from this chain from any other output. So let's try that. So here I'm going to just put out just some minor signs there just so we can really see that the difference here. We're going to change this concat line now. We've got concat stream.distinct.count. We're going to leave the dot distinct in, then add one line here after the distinct to put dot peek. We're going to do system.out : println, and finish with a dot count. And what we might do, just to make this a little bit more readable, let's actually put these on separate lines. I find when with chaining operations, it's actually good to put them on separate lines. It's a little bit easy to read. All right, so let's actually try running that. So you can see we've got the 6 distinct items in the stream that was returned from distinct, followed by the count. Now the documentation states for the peek method, it mainly exists to support debugging, and that's obviously what we're using it for here, to be able to print that out as we go through and show the elements that actually remain after the distinct was called. Alright, so I'm going to finish the video here now. In the next video we'll continue on and we'll actually look at the flat map method. So I'll see you in the next video.